Welcome to the Converge Construction Hazard Assessment Training Program. Every time we arrive at work, there are always at least two goals in mind. The first focuses on the work to be done. This is the reason we came to the job in the first place. The second goal is less obvious most days. That is the expectation that we will go home at the end of the day. Taking the time to conduct an accurate hazard assessment before work starts will help prevent the incidents or injuries that will hinder us from reaching both of these goals. A 10-minute huddle at the beginning of the shift is well worth the investment, and it meets part of the requirements of Workers' Compensation Act Part 2, Division 4, under Section 21, Paragraph 2B, Sentence 1, and Section 23, Paragraph 2A, Sentence 1, that state the responsibility of the employer and supervisor to make workers aware of the hazards in their workplace. It also fulfills part of the requirement for workers to be involved in their employer's occupational health and safety program. To complete a hazard assessment, there are 5 key elements to understand. The first 2 are objective observations, tasks, and hazards. The next 2 are measurements, severity, and exposure. The final element is simple math, risk. The level of risk will be what determines the appropriate controls. The first 4 elements will give us the information we need to make that assessment. We'll start with how to break down the work to be done into tasks. We will begin by looking at how to assess the tasks to be done. This is the first step, and it is often where the process begins to break down, because we don't understand the difference between the work to be done and the tasks to be done. It sounds like the same thing. Changing the words will help. If you look at the work as a procedure, then the tasks are the steps that need to be done to complete the procedure. The next problem is understanding how to break a day's work into tasks that allow for a meaningful assessment to be completed. Some examples are: framing of a second floor is beginning today. Installing of catch basins as part of the off-site work. Or installation of windows and doors is starting today. Each of these will involve multiple tasks to reach completion. Without breaking it into tasks, the smaller individual steps are easily overlooked and hazards will be missed. The other problem is focusing too closely and going past the tasks right down to the individual steps necessary to do those tasks. This will either end up in a meaningless pile of paperwork or someone being too overwhelmed to even complete the assessment. Don't do it. If you are installing windows and doors, don't break it down to the point where you're assessing the hazard of replacing a blade in a box cutter, right? We will look next at how to break work down into meaningful tasks for a proper hazard assessment. Going back to our 3 examples, it is simple for experienced workers to hear these at the beginning of the day and already have a good idea of what needs to happen. However, without taking the few minutes for an assessment, this can lead to having a focus that is too wide and missing critical tasks. It is critical to understand that while the goal of the work is the same from job to job, that is where the similarity ends. There are numerous considerations that will change what tasks need to be done to complete the work. The location of the work, the access to the site and the work zone, other activities in and around the work zone, new materials in use, supplying power, air, etc. to the work zone, specialized tools, and even weather or time of day. All of these change how the work will be done. Every change may include new or unexpected hazards. Think about how any one of these changes could affect the work you do. Would it involve new or different controls to ensure the work is completed safely? With this in mind, let's look at how we can separate the work into tasks. We'll use the first example and break it into 4 tasks with one question aimed at identifying a possible hazard. The method would be the same for all the examples. Second floor framing starts today. Task 1, materials. How will the materials be delivered to the work zone and stored? Task 2, lay out and build the walls. How will the walls be lifted? Task 3. It started snowing shortly after the wall building started. It was in the forecast. How do we deal with this? Task 4. Trusses arrive in the morning. How are we prepping the crane access and placement area? In the case of a simple day of framing, it would be easy to overlook Task 1. The materials are being delivered with a high ebb. The crane access and the swing path need to be considered. Task 2. Some of the walls may exceed a safe load for the number of workers available. Task 3. Until the walls are all erected, there will be fall edges that are getting more slippery as the snow continues to fall. Task 4. A crane placement should never be done on the spur of the moment. Breaking down the work into these separate tasks will ensure that each step is properly assessed. However, adding a task for cutting the banding from the lift of studs is where we would cross the line into micromanaging the assessment. That should be common sense. Next, we will look at the hazards. We will begin this section by looking at the difference between hazards and risks. These terms are not interchangeable. A hazard is any source of potential damage, harm, or adverse health effects on something or someone. Risk is the possibility of it happening. These terms work together in the assessment process to generate the correct controls, but they must be understood separately. A hazard is identified by objective observation, and for the purpose of completing an assessment, the hazard will always be rated as if there were no controls in place. As we will see later, risk is a more subjective assessment. Once the work has been broken down into tasks, the identification of hazards is probably the most straightforward part of an assessment. However, experience and inexperience can cause oversights. A simple approach is to begin with the most obvious or critical hazards, such as falls from height, energy releases, struck by sources, and other high-impact hazards, and then start to look at lower-impact hazards. The reasons for this are that the high-impact hazards will obviously need the most detailed controls and will have more dire outcomes, while the lower-impact hazards will often be controlled with simple shifts in work practices. It is important to remember not to stop the assessment after identifying and controlling the critical hazards. Completing an assessment that only considers the critical tasks will overlook the #minor hazards that contribute to the highest number of workplace injuries and incidents. This thinking leads to hazard assessments being omitted on workdays that do not include high hazard procedures. This is a mistake. Again, there is no need to micromanage, but there is a need to consider tool and equipment inspections that may identify faulty items that need to be repaired or removed from service, housekeeping that leads to slip-trip hazards, and other seemingly minor issues that can end in rolled ankles, lacerations, falls on the same level, or any number of other injuries. That doesn't even cover time lost to tool and equipment breakdowns. Best practice. A hazard assessment must always be viewed as a living document. What this means is that there is always room for input and revisions as needed. Critical part of a proper assessment is for all of the workers involved in the tasks to have a say in identifying and controlling potential hazards. WorkSafe BC legislation gives workers the right to participate in their employer's health and safety program, and more eyes on the assessment will also make a safer work zone. In the next section, we will look at how to classify hazards so that we can respond with the best controls. Severity refers to what will happen if a hazard is not properly controlled. Using the definition for hazard, severity is assessing the level of damage or harm that would result. When we look at a hazard, the measurement for severity is answered by asking, what could happen? The answer to this question will sometimes depend on the skill and experience of the workers, but if we consider too many variables like this, we will get into the paralysis of analysis. This will never help us reach our goal of assessing and controlling hazards so that work can progress without undue interventions. We need to keep it simple. A worker using a box cutter may cut their hand, but we don't need to push the scenario to an extreme, where the worker may lose 3 fingers anytime they use the tool. That's excessive, and the controls would not make any sense. On the other hand, a worker who may end up under the swing path of a crane with a 13,000-ton load will want to consider more than simple PPE as a control. The outcome of this hazard would be fatal. Severity will be rated on a scale using terms ranging from trivial to fatal. Generally, a hazard assessment will list the ratings from 1 to 5 with terms like 1. Trivial, 2. Minor, 3. Time loss, 4. Life-altering, and 5. Fatal. You may see different terms, but the idea is the same. How bad will it be if something goes wrong? When we use simple logic to assess the severity of a hazard, it is easy to come to an objective answer. Again, the goal is to generate a reasonable assessment, not unreasonable fear. Before we move on to risk, the next consideration is exposure. Exposure is the amount of time a worker is in harm's way, the concentrations of hazardous materials, or the levels of energy a worker will be exposed to. Our end goal for a hazard assessment is to determine the risk, and the math is to multiply the level of possible outcome of a hazard by the amount of exposure to the hazard. Again, keep in mind that these assessments are done with no controls in place. Reference to exposure limits are found throughout the regulations. The most obvious examples are in Part 6 for substance-specific requirements, where exposures to different materials are rated by time and amounts. More subtle examples would be the working load limits on rigging equipment or design loads of temporary floors. Each of these examples is looking at an objective quantity from which an assessment can be made. Now that we have two quantities, the severity of outcome and exposure, we will look at doing the math to determine the risk. We have found that risk is a measurement of the relationship between the outcomes of a hazard and the time of exposure to the hazard. The math can be represented by graphing both elements. On this graph, an increase in the severity of the outcome will increase vertically, and the time a worker is exposed to the hazard will increase to the right. Note that the curved line represents the increasing probability as time progresses, and the shaded area represents the increasing risk. The graph shows that the red shaded area will increase in two ways. The first way is for a worker to be exposed to a hazard for a long time. A short exposure drastically reduces the probability of an incident, but the longer a worker is exposed, the more the probability increases. The second way is for a worker to be exposed to a severe hazard for any duration. It is important to remember that a short exposure to an extreme hazard will not reduce the risk enough to allow for minimal controls to be used. Note that a higher risk does not mean a more severe outcome. It simply means there is a higher probability that a worker will be on the receiving end of the hazard. Statistically, the longer you expose to a hazard, the greater the possibility you will be injured. That's a lot of words, but it's just a little bit of simple math. Severity of outcome times time or exposure equals risk. This simple method of assessing hazards will allow supervisors and workers to select the right equipment and procedures to mitigate the risk. Here are two quick scenarios to show how this works. Number 1, I'm out for a walk and see that the city crews have put up some Jersey barriers on the side street I usually go down. I decide to hop up and test my balance. No traffic, no ditches, no worries. Just my familiar neighborhood. Now suppose we switch it up for scenario number 2. Still out for a walk, but I decide to take a different route. Now the Jersey barriers are running between multiple lanes of busy city traffic. What could possibly go wrong? Right? Scenario 1 goes sideways and I maybe roll my ankle or bash my knee on the barrier. Scenario 2 goes wrong and I probably won't remember it when I come to in the hospital. Proper assessments of risk will bring the reward of going home at the end of the day. As was said before, we're not looking to bring fear into the equation, but we're also wanting to be level-headed. What this means is that if we step into a high-risk scenario, we don't want to rely on our wits and experience combined with some basic PPE. We want to look at how we can be better prepared to control the hazard, or, better yet, at the top of the hazard control hierarchy is the option to eliminate the hazard altogether. In the end, hazard assessments are simple math. The higher the risk, the greater the controls necessary to ensure positive outcomes. Whichever option we choose, it will only be properly informed by taking a few minutes to assess what we are dealing with in the first place. Elimination is at the top of the list of preferred controls for an obvious reason. Once eliminated, the hazard no longer exists. The top of the list is hard to achieve though, and although it is best in theory, in practice it is not always practicable. The problem is that this difficulty can make it easy to just skip right past this control option. Many times, once the skipping starts, workers will skip right past the elimination option and go for the PPE solution. The danger behind this process of deciding on a control is that it doesn't really look at the possible outcomes. It tends to rely on perceived skills and experience. PPE ceases to be the lowest form of control and actually increases the sense of safety. A careful consideration of a high hazard environment may open the door to a different solution. Substitution is the next rung on the ladder as we work our way down the hierarchy of controls. This level of control will ask you whether there is another tool, process, material, chemical, design, travel route, etc. that will get the job done with lower risk to workers. This control can also be a hard sell because businesses tend to stick with ways that have proven profitability. If you think about it though, many ways and means we use now were once new ways and means. Consideration of different options often leads to better, more efficient, and more profitable outcomes. And of course, there is no substitution for keeping our workforce working better, which always leads to a profitable outcome. Engineering controls are where we begin to see the more common methods of controlling and mitigating hazards. Many engineering controls will not require a significant change to work procedures and will use materials already present in the workplace, making them straightforward methods of mitigating hazards. A key point to remember about these controls is right in the name. Engineered controls will most often have specific design requirements to be compliant, and it is essential that these requirements are understood by both supervisors and workers. Engineering controls will generally fall into three categories: isolation or enclosure, process controls, guarding or shielding. Common examples of engineering controls are guardrails, machine guards on everything from power tools to heavy equipment, ventilation systems, wetting systems for cutting or grinding, hydraulic lifts, and various forms of flow controls. Administrative and PPE controls are at the bottom of the list and are the least effective methods. Administrative controls are referred to as pre-contact controls because they are designed to limit the exposure to hazards through procedures, training, or changing the duration of the work. Signs are another administrative control. They are used to warn or inform workers of hazards present in their workplace. When you are donning PPE, it is important to remember you are on the bottom rung of the controls ladder. This does not mean that these controls are ineffective, it just means that you need to be aware. These controls are referred to as contact controls because you will be exposed to the hazard while using it. This is why it is important for workers to know what PPE to use, how to use it, how to inspect it, and how to care for it. PPE items are all required to be engineered to specific standards, but this does not make them engineered controls. So, understanding the role of exposure in assessing the risk is very important. In conclusion, the math involved in disregarding hazard assessments needs to consider the costs of injuries and incidents in the workplace. These costs can include work delays, hiring and retraining, equipment replacements, injury management, and claims costs. When you consider the possible outcomes, the perceived savings of skipping the 5 or 10 minutes to complete an assessment quickly evaporate. When you understand how to do it, the math involved in assessing hazards is basic, and there are only 5 steps to remember. 1. Identify the hazards. 2. Assess the severity from 1 to 5. 3. Prioritize the risk by multiplying the severity by the exposure to the hazard. 4. Control the hazard using the hierarchy of controls. And 5. Communicate the assessment with a documented pre-job or field-level hazard assessment. Completing an assessment of the risks also brings the added benefits of 1. Ensuring that all the workers involved understand the tasks. 2. Ensuring all of the equipment, tools, and materials are ready to go. 3. Ensuring workers are actively involved in worksite health and safety. At the end of it all, the goal is to ensure everyone goes home healthy, and that is a huge payout for a small investment of time.